So good morning students. So now we'll go with the differentiation. So now after I complete with differentiation, then integration, then I will go with the differential equation. Now in case of differentiation, we have first one, it is algebraic differentiation, which is going to work for both science, commerce and arts for all the class 12. But when it comes to trigonometric differentiation, this we don't need to, commerce and business mathematics, for this commerce student, they don't need to go with trigonometric, logarithmic and exponential, as well as the inverse. But for science you have to do it all. For commerce you don't need to go with trigonometric differentiation, logarithmic, exponential and inverse differentiation. And now when it comes to implicit science will do all the points here till 11, all the questions, all the sub chapters. But when it comes to implicit, commerce student will do only the implicit question, which is purely based on algebraic. Okay, implicit, parametric, and the function with respect to another function. Like no need to go with the higher logarithmic for commerce student, commerce and arts student. Second order as well. Then for maxima and minima. So under maxima and minima we have 4 applications. First one we will do turning points on the curves. Next one is application on numbers, then geometrical figures and the mensurations. So let's go with first one, which is our algebraic differentiation. Okay, so let's go with the algebraic differentiation. Now under algebraic differentiation, first we'll go with the power rule. So what is this power rule? Suppose we have this function y is equal to x raised to power n, where n value is not equal to 0. What's the reason behind that n value should not be equal to 0? See here, if you say n value is equivalent to 0, this becomes x raised to power 0, which is equivalent to x raised to power 0 is equivalent to 1. That means when you differentiate the rate of change of y with respect to x, that means it's a differentiation, is a calculus, is a rate of change. I have explained in previous video. Rate of change of y with respect to x is differentiation of constant which is equivalent to 0. Which is not possible, because rate of change means you need to have some constant value. If there's any changes, then you will get some result. But here result is equivalent to 0. So rate of change should not be equivalent to 0. That is why what I can do here it is, here, when you differentiate this function now, as per the power rule, dy by dx is equivalent to n x raised to n minus 1. This is known as a power rule. You bring this n in front, then subtract minus 1. This is the power rule. Example, if I say, if you have y is equal to x raised to power 5, you can take 5 value. Other than 0, you can take any value, whether it's a positive or whether it's a negative value. When you differentiate, dy by dx is equivalent to 5x raised to 5 minus 1, which is 5x raised to power 4. This is the value. This is known as a power rule. Next one we will see, here it is called constant rule. Number 2, we call this one as a constant rule. So under constant rule, it says differentiation of any constant c is equivalent to 0. Please remember, this is a power rule, and then we have differentiation of constant is always equivalent to 0. Then after this, now what we need to learn here, we need to learn the special cases. Okay, so now we will go with the special cases, and make sure you make thorough with this special cases. Okay, so every question usually I use the special cases, so make it thorough. So special cases, in case of number 1, let me see what's the differentiation of y is equivalent to x. If y is equivalent to x, you know what's n value here? N value is equivalent to 1. So when you differentiate as per the power rule, dy by dx is equal to 1x raised to 1 minus 1. This is the n value, you bring it from, then n minus 1, which is equivalent to 1 times x raised to power 0, which is 1 times x raised to power 0 is 1, which is equivalent to 1. So differentiation here, differentiation of, okay, dy by dx of x is equivalent to 1. Okay, dy by dx. Y means the value of x. Dy by dx is always equivalent to 1. Differentiation of constant is 0. Differentiation of x is equivalent to 1. Next one, what we will see here is, what if we have y is equal to 1 by x? So now, usually what you people will do here is, usually the method you will do here is, if you have y is equal to 1 by x, what you will do? You will always try to bring it up, because to differentiate as per the power rule, the x should be always in numerator. So why we have is x is to minus 1. When you bring up, definitely the sign will change. That implies dy by dx will be negative 1, x is to negative 1 minus 1, n minus 1. N value here it is negative 1. So negative 1, x is to negative 1 minus 1, which is equal to negative 1, x is to negative 2, which is negative 1 divided by x squared. Isn't it? Bring minus 2. So now we will not follow this long process. That is why please follow this special cases. Usually I will use the special cases. So what I can do here is differentiation of 1 by x is equivalent to negative 1 by x squared. Okay? Please try to get the pattern. Differentiation of 1 by x squared is equivalent to negative 2 divided by x cubed. Then similarly here, differentiation of 1 by x cubed is nothing but, it is negative 3 divided by x raised to power 4. I hope you are getting the pattern. Please try to get the pattern here. Then, if you have next one, differentiation of 1 by x raised to power 4 is nothing but, it is negative 4 divided by x raised to power 5. It's very simple. See, whenever you have x in denominator, answer you will get is in negative. Okay? X in numerator, you will answer get is in positive. When x is in denominator, answer you will get is negative. What's the power of x here? Power of x is 1. That 1 will come here. But here in denominator, the power of x will increase by 1. Isn't it? So see this case. Answer is in negative. This 2 is coming in numerator. And the power of x is increasing by 1, which is equivalent to 3. Similarly, see this case. Here answer comes in negative. This 4 comes here. Power of x is increased by 1, which becomes x is power 5. Then, let me go another one. If I see differentiation of 1, okay, 2 by x is to power 6. Now we can do it directly. No need to bring this one up. What will be the answer? Answer will be negative 12 divided by x is to power 7. Isn't it? This 6 will come up, answer will be negative. This becomes power will increase by 1. Similarly, let me go one more. Differentiation of, okay, differentiation of, okay, negative 3 divided by x is to power 5. What will be answer? Answer will be negative. That negative and this negative becomes positive. 5 times 3 becomes 15. 15 divided by x is to power 6. X is to power 6. I hope you got it, this one. Because see, special cases are very important. Last year you must have learned by bringing this one up and then using all this method. It is a long process. Because when you encounter this function in between, suppose say y is equal to log of sine square of negative 2 by x cube, suppose say, or whole cube, then it will be very difficult by bringing this one up. You can use it directly, use the special cases. Right? So therefore please get thorough with the special cases and then do not follow the last year's method that where you tend to bring on up, okay? If you have this kind of method, please don't do it. Get thorough with the special cases tonight. I hope you understood this one. So next we'll go special cases number 3. So what is the differentiation of root x? You have already seen. Actually, if you need to calculate these, what you will do? Okay, if you have y is equal to root x, usually what you will do? You will write this one as x is to half. When it index here it is 2, so you will bring out in change in exponential. That here you use the power rule. When you use power rule, okay, dy by dx is equal to half x is to half minus 1. That's a power rule, right? So which is equal to 1 by 2, x is to half minus 1 is minus half. Bring this down, which is 1 by 2 x is to minus half. When you bring down, it becomes positive half. That again change back to root. This becomes 1 by 2 root x. This is a normal method you do, okay? But here in my case, here we will never use this concept, okay? So see, differentiation of root x is 1 by 2 root x. Please try to get the pattern, okay? Differentiation of cube root of x is equivalent to 1 by 3 cube root of x square. I hope you are getting? Isn't it? Next one it is differentiation of, try to get the pattern, please, try to get the pattern. 4th root of x is 1 by 4 4th root of x cube. I hope you are getting pattern now. What do you think now? What do you think about this one? Differentiation of 5th root of x. So what is happening here is, see, here you can see index here is 2. We don't write this one as a square root. This index come here. Index remains same. Answer is in positive because it is in numerator. If it is in numerator, if the function is in numerator, answer you will get is positive. If the function is in denominator, answer you will get is negative. Then the power of this x is decreased by 1. Answer positive means power will decrease. If answer comes negative means power will increase. So here the power of x is decreased by 1 with respect to index. See here, what's the index here? 3. 3 comes here, index remains same. Power of x is decreased by 1 with respect to index. Tell me now what will be this now? 1 divided by 5 5th root of x raised to power 4. Index will come here, index remains same, but power of x will decrease by 1 if the answer is in positive. See, my method, you will find a little bit difficult, I know that one, okay? So, but if you start working right now, okay, if you work hard right now and try to get these special cases, I will assure you the calculus, that's the differentiation quotient, will be very easy using special cases. Don't ever differentiate by changing this x's to 1 by 5 and don't do this in method. It's a very long process. Okay? So please try to get these special cases and make it thorough. Okay? Now after this we'll see the last one. Okay? Last special cases. Let's see what's the differentiation of 1 by root x. So normally what you will do, if you have y is equal to root x, first change this one. This will be y is equal to x raised to half. Bring this one up, this becomes x raised to minus half. It's a very long process, I'm telling you. And value is negative half. Use power rule. That implies divide by dx is equal to negative 1 by 2. And you will come in front x raised to negative 1 by 2 minus 1. Is that right? So every time no need to write, I will tell you later, okay? So negative 1 by 2 x raised to 2 LCM to 1 is 2. It is negative 3 by 2. Bring this down. We have negative 1 by 2x raised to 3 by 2. Changing root form, this is the exponential form which is negative 1 by 2 times. You know this is a index, okay? So we have index of x cube. Or you can write this one as a negative 1 by 2 root of x whole cube. Meaning is same, okay? Whether you write this cube inside or outside, meaning is same. So now what's the differentiation of 1 by root x? It is negative 1 by 2 times root of x cubed. Similarly, let's try to get the pattern now. Differentiation of 1 by cube root of x. See this? Negative 1 by 3 cube root of x raised to power 4. Again, d by dx of 1 by 4th root of x, which is equivalent to negative 1 by 4th root of x raised to power 5. Try to get these special cases, please, okay? Usually I will solve this one. If you are not thorough with the special case, then you will not understand the differentiation. Now, what would be now differentiation of 1 by 5th root of x? What's happening? Root x is in denominator, so answer you will get in negative. This index 4 will come here. Index remains same, but power of x will increase by 1 with respect to index. Previous case, differentiation of root x, answer was in positive, but power of x was decreased by 1 with respect to index. This case, answer is negative, but power of x will increase by 1 with respect to index. Get thorough with this one. What should be now 1 by 5th root of x? It will be negative 1 by 5 5th root of x raised to power 6. I hope you got this one. You can try yourself. You give any value and try with the special cases. Please make thorough with the special cases before I start solving the problems under differentiation. So that's it. So we have 4 special cases. So I will continuously use the special cases.